At an experiment that demonstrates Le Chatelier's principle using the reaction between iron 3 chloride and potassium thiocyanate. So, as I've just said, in our experiment we're going to illustrate Le Chatelier's principle using a reaction between iron 3 chloride and potassium thiocyanate. So we use iron 3 chloride as our source of iron 3 plus ions, and we use potassium thiocyanate as our source of thiocyanate ions. So our iron 3 ions are yellow in colour and the thiocyanate is colourless. However, when the two combine, an equilibrium reaction is set up involving the production of ferrothiocyanate, and that is a red colour. So as you can see here, we've got the yellow colour at the start, where we just have the iron 3 plus and the thiocyanate, but as the reaction occurs, we can see that we form this kind of blood red colour. So in this experiment we're going to look at the effect that concentration and temperature have on the position of the equilibrium in this reaction. So the first thing that we'll do is we'll look at concentration. So you mix about 5 centimetres cubed of your iron 3 chloride and a few drops of your potassium thiocyanate, and you do get your ferrothiocyanate ion at the end with some chloride ions. So when we mix them together, we can see that a red colour is obtained. So this red colour is indicating the production of our ferrothiocyanate. So we've got the yellow going to the red. Now, what we do is we add some dilute hydrochloric acid, and what this does is this causes an increase in the concentration of the chloride ions present. So we're applying a stress that increases the concentration of chloride ions on the right hand side of our equation. So that would mean that if there's excess chloride ions present, the reaction is going to happen that gets rid of those chloride ions. So that means the backward reaction would happen. So equilibrium will shift to the left here in order to absorb the extra Cl- ions that have been added, and we form iron 3 chloride. So that means that the red colour will become yellow. On the contrary, if we added some dilute potassium thiocyanate, we would see here that adding the potassium thiocyanate would increase the concentration of the thiocyanate ion on the left-hand side of the equation. So to counteract that increase in concentration, they're going to want to get those thiocyanate ions to react. So it's going to push the forward reaction. So as I said here, an increase in the concentration of the thiocyanate ion present causes equilibrium to shift to the right to absorb the extra thiocyanate ions, and it forms the ferrothiocyanate, and we go from our yellow colour to a red colour. Now, if the solution is already red, it will just become a darker red, because as we increase the thiocyanate concentration, more and more of this ferrothiocyanate will be formed, so the red colour would just become deeper. So next we'll look at the effect that temperature has on the equilibrium. So what we'll do is we mix together our iron 3 chloride and our potassium thiocyanate again, and that gives us our ferrothiocyanate. And we know that the forward reaction is exothermic and the backward reaction is endothermic. So exothermic means that heat has been given out, and endothermic means that heat has been absorbed. And you should remember that from rates of reaction and from our thermochemistry. So if we place our test tube that has the ferrothiocyanate in it, if we place it in a beaker of hot water, the red colour that we have becomes lighter. So it's important for us to remember that our product side is red and that our reactant side is yellow. So the equilibrium here has shifted to the left in order to absorb the heat that is added. So to explain this, we know that if we add heat, we're causing a stress. So what we're going to want to do is we're going to want to reduce that stress. So the only way to reduce to get rid of heat is to cool it down. So we would favour the endothermic reaction, because the endothermic reaction means that it can absorb heat. So that's why equilibrium shifts to the left side, because the left side, or the reverse reaction, is favoured when there is an increase in temperature. So let's look now at what happens if we placed the test tube of the ferrothiocyanate in a beaker of ice. Now, if we placed it in a beaker of ice, we would find that the red colour becomes darker. So the red colour becoming darker means that the equilibrium has shifted to the right, and this is in order to replace the heat lost. So that means the exothermic reaction is favoured. So to explain that, if we cool something down, the automatic reaction that you'll want to do, if you're cold, the automatic thing you want to do is to heat up. So we know that an exothermic reaction is a reaction that gives out heat. So we know that the exothermic reaction will be favoured when the beaker is placed in ice, because you want to counteract that cold temperature by having an exothermic reaction. So that's why the forward reaction is favoured. So let's look at some sample exam questions that can come up with this experiment. So what conclusion can be drawn from the fact that the red colour of the mixture of FeCl3 or iron 3 chloride and potassium thiocyanate becomes lighter when placed in hot water? So we know that the red colour becomes lighter when it's placed in hot water because the endothermic reaction is favoured, because heating is a stress, and in order to counteract that stress, you'll want to have the cooling reaction, which is an endothermic reaction. So as I've said here, the red colour becomes lighter. This means equilibrium is shifted to the left in order to absorb the heat added, so the endothermic reaction is favoured. The next question then, it says, use Le Chatelier's principle to predict what will be observed when a test tube containing a mixture of iron 3 chloride and potassium thiocyanate is placed in ice. Now, if you're placing something in ice, you're cooling it down, you're making it cold. So the reaction that you're going to get is going to be one that will cause it to heat up. So placing the test tube in a beaker of ice, the red colour will become darker. And the reason the red colour will become darker is because equilibrium is shifted to the right in order to replace the heat that's lost. So the exothermic reaction is favoured. The last question that I'll go through is, hydrochloric acid was used to change the position of the equilibrium of the reaction between iron 3 chloride and potassium thiocyanate. Name another compound that would have a similar effect. And you could really pick any sort of compound that contains chloride, so potassium chloride or sodium chloride, as I have said here. So that's it for this video. Have a read over the learning intentions to make sure you understand everything we've gone through.